Hi, so we are going to go over standard N-RN.1.2 and N-RN.1.1. So let's go ahead and we're going to talk about fractional exponents. So what happens, this is a reminder of what happens when you have a fraction in your exponent. Well, I always think about it where the bottom of your fraction is going to come out, and then the top of the fraction, which is that 1, is going to stay to the top of your number. Now, you're wondering where the 1 went from. We could put a 1 above it, but 4 to the 1 power is still 4, so that's why they got rid of it. So let's do this example. So we have square root of 32 equals 2 raised to the 5 over 2. Let's go ahead and try to change 2 raised to the 5 over 2 to see if it's the same kind of radical. So we have the top number stays as the top of his number, 2 to the 5th power. Now, we can write the 2 out here. However, it's kind of, that square root symbol already means to square root it, so we no longer need that 2. So we can go ahead and get rid of it. So let's just do 2 to the 5th power. And it just so happens that 2 to the 5th power is 32. So this is a true statement. All right, we're going to do the same with the second one. We're actually going to turn this fraction into a radical. So we have 16. The 3 is going to stay on top because it's on the top of the fraction, and this is an 8th root. Well, you don't need to plug this into your calculator because we can already see that this is probably not going to be the same. It's just 8 squared. All right, so let's do this example. So what I'm going to do is I'm actually going to turn this into a fractional exponent to see if they match. So we have 64. The top of 64, the exponent's already there, is going to be the top of your fraction, which is 1, and it's going to be 1/4. So we can easily see, oops, sorry, that was false, that 64 raised to the 1/4 power is not the same as 4 raised to the 1/2 power. All right, we're going to do the second one, and what I'm going to do is when we have a power raised, that means we have to multiply this number to whatever this one has an exponent. Well, it doesn't have an exponent at the moment, so we're going to flip some stuff around to make sure that happens. So we have 16 to the 1/3 power raised to the 6th. Using your exponent rules, if you have a power raised to a power, this becomes 16 times 1, or raised to the 1/3 times 6 over 1. Then we have 6 over 3, which is going to simplify to 2. So at first, you can't really tell if 16 squared equals 2 to the 8th power, but we can use our calculator to do that. So how you do that is 2. To raise something to whatever power you want, you click this button. 2 raised to the 8th power, 256. Now let's try 16 raised to the 2nd power. So we have 16, and this already has a cute little button raised to the 2nd power. We don't have to do all that. It is also 256. So this is a true statement. All right, so let's do the bottom one. Now, if you're wondering why this fraction, your exponent, is outside the parentheses, it means it wants you to multiply that fractional exponent to 64's fractional exponent, which it's not there at the moment, but we can put it there. So remember, that's just an invisible 2, and that's an invisible 1. So we have 64 raised to the 1/2, raise that to the 1/3. Okay, so we're going to multiply. So we have 64 raised to the 1/2 times 1/3, which is 64 to the 1/6. All right, so we can easily see here that 64 to the 1/6 power is not going to equal 8 to the 1/6 power. So this statement is false. Alrighty, so for this one, we are going to see if we are going to multiply these two together to see which one it is. And I'm going to give you a heads up, okay, when it comes to this stuff. We are practicing here how to turn these into fractional exponents. When you also need to know your exponent rules. So before you go forward with this, you need to understand all of your exponent rules, and you need to understand how to add fractions. So those are prerequisite knowledge you're going to need for this. So if I go about it a little fast, I would go back and practice those two things and then see how you feel. So what I am going to do is I'm going to turn both of these into where they have a fractional exponent. So x, because 2 is on top of the x, it's going to be on top of the fraction, times, because the 5 is on top of the x, it's going to be on top of the fraction. And although there's not a 2 here, it's there. So now that we know that rule, now we have to know what happens when you are multiplying exponents. So if you multiply bases, you add exponents. So this turns into x. If you multiply bases, you add exponents. So what I'm going to do is I'm going to do a different color, and I'm going to add those exponents kind of out in the bottom, just so it's a whole separate thing. So we have 2/3 plus 5/2. Now if you can remember, when you add fractions, you have to have common denominators. So the smallest number that both 3 and 2 equally go into is 6. You might have learned different methods before. This is just kind of what we call the butterfly method. So in order to get from 3 to 6, I had to multiply by 2, which means I have to multiply the 2 by 2. So that turns it into 4. How did I get from 2 to 6? Well, I multiplied it by 3, so I have to multiply the 5 by 3. That turns it into 15. Now you see why it's called the butterfly method. Kind of looks like a butterfly. All right, once you have common denominators, you add the tops, keep the bottoms. So we have 19/6. And I can't simplify that fraction at all. It is what it is. So we're going to take that number, and I'm going to put it at the top. 19. Let me go back to that blue. All right, so now we have that. Now we just have to, our answers are in radical form. So let's find a radical form. 19's at the top of the fraction, so it's going to stay at the top of x, and that 6 comes out. So your answer is D. Alrighty, so let's go ahead and do number 5. So when you have something like this, that 2/3 has to be distributed to the 8 and the x cubed. So that's going to turn into here, times. Now when you have a power raised to a power, you multiply them. So we have x to the 3/1 times 2/3. If you want to cross cancel, these turns into 1s, and we have x squared. So if for any reason you didn't remember that this turns into 8 square root 2 with a cube root, and then a cube root of 64 is 4. Let's say you didn't remember that, or you didn't know how to type that in your calculator. If you just focus on this x squared, if you knew that rule, then you can automatically go ahead and just say, I know it's A, because I know the exponent above my x is correct. Okay, so let's go and do number 2. So 4 students rewrote the expression in radical form, just like this. Who has written it correctly? So remember, we have m to the 5/3. All right, so the top of the fraction stays with the top of the number. The other guy comes on the outside. So the person who wrote it right is Alicia. It's a good name. Alrighty, so let's do this one. 4 students were asked to solve an equation below. Their answer are as follows. So we have 5 to the 1/3 times something equals 5. So what we're going to do is we're going to determine which one of these, and there could be more, are correct. Alrighty, so 4 students were asked to solve this equation, and we're going to tell which one is right. So basically we have to multiply these by this to see if we get a 5. So what I'm going to do is I'm going to change 5 1/3 to the cube root of 5, because it's easier So when you have a cube root of 25 times the cube root of 5, when you have the same exact root, you're going to keep that root and just multiply what's underneath the radical. So 25 times 5 is 125. So now let's go ahead and see if that equals 5. So we have to try to find numbers times itself 3 times that will equal 125. So if we did like 2 times 2 times 2, that's 8. 3 times 3 times 3 is 27. And if you continue on with this trend, you will see that 5 times 5 times 5 is 125. So Alberto is correct. So let's try a ratio. So I'm going to grab red. So again, we have the cube root of 125 times the cube root of 5. Now, I'm going to go ahead and tell you ahead of time. You can do 125 times 5, and you're going to get some huge number in here. And we can do that if you want to. But we've already determined that the cube root of 125 is how we get 5. So any other number in here would not give us 5. So this is a standard that is going to be in the non-calculator portion, so I'm just trying to teach you some test-taking skills. So it doesn't really matter what we have in here. So it's not ratio, can't be her. All right, so let's keep going down the line. Let's do Sharon. Now this one is a little bit different. I am going to keep 5 1/3 in the way it is, just like it was given to us, because I'm going to multiply 5 times 2/3. When you multiply bases, you add exponents, so this turns into 5 1/3 plus 2/3, which equals 5 to the 3/3, which just translates to 1, which just translates to 5. So Sharon is right as well. So again, we can sit here and determine that if 5 2/3 times this is how I get 5. 5 to the 3rd power, if it's going to be the same exact process, it's not going to give you 5 because we already determined the exponent that will work. So Sharon and Alberto are the ones that are correct. So that's the end of your exponent rule standard. So again, you can go into USA Test Prep. You can monitor the standard using your dot ranks. If you have questions, feel free to email your teachers.